welcome to 8.2 sine and cosine ratios. So, hold on just a second while I get everything available that we're going to want to use. There we go. In the previous lesson, we talked about the tangent ratio. So I was draw a reasonably nice right-angled triangle with my right angle here. And I'm just going to put a random angle in here. We're going to look at this angle, and I'm going to just put some symbols for all of my sides. Let's call this X, Y, Z, just to be a little bit different. And we identified our tangent ratio is the opposite over adjacent. So in this case would be Y. Well, let's start off by writing an equation. Opposite over adjacent. So in this scenario, my tangent ratio is going to be Y over X. There is also a sine ratio and cosine ratio. My sine ratio is equal to opposite over hypotenuse, and my cosine ratio is equal to adjacent over hypotenuse. There is potential for about another 9 ratios depending on how you mix the sides, but sine ratio, cosine ratio, and tan ratio are considered the 3 primary ratios. And really, for most math, those are all you need: sine, cos, and tan. So the sine ratio is usually shortened to SIN, and if I was to write it like our tan ratio, we'd write it like this: sine of theta is equal to opposite over hypotenuse. And cosine ratio is usually shortened to cos. Theta is equal to adjacent over hypotenuse. So if we had a bit of a numeric example, we'll scribble another triangle here. And let's make this a 7 and an 8. Actually, just give me the variables. For now, let's call this A, B, and C, and the sine ratio. Let's look from this angle. My sine ratio would then be opposite over hypotenuse. I've got my theta there. My cosine ratio would be adjacent over hypotenuse, and my tangent ratio would be opposite over adjacent. So when you use the sine ratio and the cosine ratio, it's exactly the way we use the tan ratios. So we can use the sine ratio, cosine ratio, or tan ratio to find an angle, and we can also use it to help us find a side. So let's look at a couple of examples about how to find an angle, and then we'll look at a couple of examples of how to find a side. Find the length of the missing side, or the indicated side. And let's just do a quick triangle. Let's call this a 2. Let's call this an X. And let's call this a, this looks like a 43 degrees to me. So the first thing we have to do when we're given a problem is we have to decide which one of these 3 ratios we're going to use. And I find it most useful to look at the angle and then label the sides from the angle. So again, I forgot to draw my 90 degrees in here, but I'm not trying to trick you. It's the one that looks like 90 degrees. So the side opposite the 90 degrees is my hypotenuse. The side opposite the angle we're looking at is opposite. And the side right next to our angle that's not the hypotenuse is going to be the adjacent. So those are my 3 sides. So notice how each one of my trigonometric ratios has 3 variables. I have an angle theta and 2 sides. So what I want to do is I want to choose the ratio that involves the two things I know and the one thing I'm looking for. If I don't know two things, I can't find anything else. It's the exact same as linear systems. I need to know everything except for one thing in order to find it. So in this case, I know an angle and the adjacent side, and I'm looking for the opposite side. So I need to figure out which one of my three trigonometric ratios I'm going to use. So I have opposite and adjacent, and you don't necessarily have to memorize these. I recommend for now maybe writing them down on a piece of paper. Maybe I'll write them down here so that you can see the tan ratio is equal to opposite over adjacent, the cos ratio is equal to adjacent over hypotenuse, and the sine ratio is equal to opposite over hypotenuse. And I'm going to choose the one that has opposite and adjacent. And that's the tan ratio. So before I put any numbers in, I'm going to start by writing down the equation without any numbers in at all. Tan of theta is equal to opposite over adjacent. My next step is to substitute in the values that I know. Don't skip the writing out the equation part. It usually results in a minor transcription error mistake. So just write it down, and then write down on your next line the numbers that you know. I know that the angle I'm using is 43 degrees. The opposite side in this case is an x, and the adjacent side is 2. Tan of 43, like we talked about in the last lesson, is just a number. I don't need to be afraid of it. You just think of it as a decimal. It's one number together, the tan of an angle, and that's it. So what I'm going to do next is I'm just going to go about trying to isolate x. X is already on the top of a fraction, so I don't need to worry about it. All I have to do is try and get it by itself. To get it by itself, in this case, I'm going to multiply both sides by 2. And I end up with 2 times tan of 43 is equal to x. So I can get my calculator out. I'm going to shrink it a little bit so I can see what's going on. And in my calculator, I can just type in 2 times the tan of 43. Close my bracket. That won't necessarily have to happen on all calculators, but this one really likes it. And I find that x in this case is equal to 0.13. Oh, I made a typo. I was like, why? That doesn't look right. 2 times the tan of 43, not just 4, is a 1.86. Let's try a couple more. We're just still going to look at finding the length of the indicated side. Quick triangle. Let's call this a 42. Let's call this side an 8. And let's try and find this side. This, I think, is example B. And I'm going to write down one more while I'm thinking about it. This looks like I'm on a 29 degrees, and let's call this side X and this one a, I don't know, 10 works for me. And while I'm thinking about it, I'm going to write down one more. Just going to make that a little bit bigger. Too small for me to write things in. There we go. Let's call this 41 degrees. Let's try and find hypotenuse. Call that 20. Cool. Let's go back to this second example, B. At the top of the page, what I frequently like to do is just write those three trigonometric ratios down. Sine theta is opposite over hypotenuse. My cos theta is equal to adjacent over hypotenuse. And my tan theta is equal to opposite over adjacent. So B, I know my angle is 42 degrees, and then I'm going to label the sides of my triangle. I know 8 is the hypotenuse. This side across from my angle is my opposite, and the side next to my angle is my adjacent. Notice how this problem has to do with my hypotenuse and my adjacent side. I know one of them, and I'm trying to find the other, and I have the angle, which means I'm going to choose the trigonometric ratio that has to do with adjacent and hypotenuse, which is cos. The cos of my angle is equal to adjacent over hypotenuse, and then my next step is to write down the numbers in it. The cos of 42 is equal to my adjacent side, which is x, over my hypotenuse, which is 8. In order to isolate x, all I have to do is multiply both sides by 8, and I end up with x is equal to 8 cos 42. Just going to move this one out of the way a bit. Now I go to my calculator and I can just type that in. 8 times cos 42. Oh, see, did it again. 8 times cos 42. So x, in this case, is equal to 5.92. Let's try this next one. C. Label the sides of our triangle. 10 is my hypotenuse. X is my opposite. This unknown side is my adjacent. I'm looking for an opposite side. I know my hypotenuse. So which one of my three trigonometric ratios has to do with opposite and hypotenuse? Sine. So I'm going to write down the equation. My sine of theta is equal to opposite over hypotenuse. Substitute the values in that I know. Sine of 29 is equal to opposite, which is x, over hypotenuse, which is 10. Solve for x. Multiply both sides by 10, and I end up with x is equal to 10 times sine 29. Once I've solved for x, I can pull out my calculator, and I can type in 10 times sine 29. And I get that x is equal to, well, I was a little bit fast that time, 4.85-ish. Let's look at D. Name the sides of our triangle. This unknown side is my adjacent. The side all the way away from the angle is my opposite, and x in this case is my hypotenuse. I am looking at my opposite and my hypotenuse, which means that I'm going to use which ratio? Opposite and hypotenuse. Sine ratio. So the sine of theta is equal to opposite over hypotenuse. Substitute my values in. The sine of 41 is equal to opposite over hypotenuse. As I write down x in a denominator at the bottom of a fraction, I need to be cautious. I cannot just follow the same steps as I have every other time. I can't just multiply by 20 and be done. X is on the denominator, so I'm going to multiply both sides by the denominator. Oh, there we go. Multiply both sides by x. So on my right-hand side, x is canceled, but x is still not all by itself. It's just no longer on the bottom of a fraction. Equal to. To get x all by itself, I have to divide by the sine of 41. Remember that sine of 41 is just a decimal. You can treat it just like it's a number. I can add, divide, multiply, subtract, all of those things. So x is equal to 20 divided by the sine of 41. I can then go to my calculator, type that in, pretty much exactly what it looks like. 20 divided by sine 41. Oh, and it messed up again. 20 divided by sine 41. Apparently proofreading is a thing on this calculator. 30.48, which is about 30.5. 30.5. The other thing we can do is we can use trigonometric ratios to find missing angles. I'm going to write down our three at the top again. Tan theta is equal to opposite over adjacent. Cos theta is equal to adjacent over hypotenuse. Sine theta is equal to opposite over hypotenuse. And we're going to talk about finding an unknown angle. Let's call this side a 3, let's call this side a 4, and let's call this side a theta. Theta is going to be the unknown angle that we're looking for. We're going to follow the exact same steps. Our first step was label the sides of the triangle. So the side opposite the right angle, the longest side is my hypotenuse. The one opposite the angle we're referencing is opposite. The one right next to it is adjacent. The two I know are the two that I can use. If I'm trying to find an angle and I don't know two sides, it's not going to work. So I'm going to use opposite and adjacent. Which trigonometric ratio involves the opposite and adjacent? In this case, it's going to be my tan ratio. So I'm going to choose to use tan. Tan theta is equal to opposite over adjacent. I write down the equation, and then I substitute my known values in. Tan theta is 3 divided by 4. So now the thing that I don't know is an angle. It's theta. And I need to try and get rid of tan. So we're going to try and do the opposite of tan. And the opposite of tan is just inverse tan. I do inverse tan to both sides. Inverse tan of tan cancels the tan, and I'm just left with theta. And then I can go to my calculator and type in however you get to your inverse tan on your calculator, 3 divided by 4. This is my inverse tan of 3/4. And I get that that angle, the calculator tells me the angle, is 36.9 degrees. Let's do B. Let's do a 7. Let's do 3. Let's call that 5. And let's try and find this angle up here. Let's call that one theta. And again, that's my little right angle symbol there. First step, name the sides of your triangles. Opposite, hypotenuse, adjacent. Next step, choose your trigonometric ratio. I know an adjacent and I know a hypotenuse. I need to choose a trigonometric ratio that has adjacent and hypotenuse in it. It is cos. Substitute my values in after I've written down the equation. Cos theta is 5 over 7. In order to get rid of cos, I do the exact same thing as I did to get rid of tan. The inverse cos gets rid of the cos, and I have to do the same thing to both sides. I'm left with theta is equal to the inverse cos of 5/7. I can get my calculator out. Inverse cos 5 divided by 7 is equal to 44.4. degrees. Let's do one more. Let's try to look at what we've done. Let's try and find this unknown angle. Step 1, identify the sides. Opposite, hypotenuse. I don't care because I don't know what it is, but that's my adjacent side. If you have those written down on a piece of paper, You need to choose the ratio that has opposite and hypotenuse in it. Opposite and hypotenuse is sine. Substitute my known values in. In order to get rid of the sine, I'm going to have to take the inverse sine of both sides. Get my calculator out. Inverse sine of 7 over 11. Oh, I hit the wrong button there. Inverse sine of 7 over 11. And I get that it's about 39.5 degrees. 39.5 degrees. It's worth mentioning that the textbook covers this all really quickly in one section, so I've attached a couple of worksheets to work on that I think are a little bit more at the Math 10 level than what the textbook goes into. But if you want some extra questions, feel free to take a look at 8.1 in the textbook.
Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.